Alright folks, Malak here, and let me tell you, some jobs are just plain messy, but absolutely critical. Today we're not mucking out a sewer or wrangling critters, but we are diving headfirst into something equally gritty and essential in the world of oil and gas. Welcome to our deep dive into the best completion techniques for unconsolidated formations. Whether you're dealing with high sand production risk or irregular well conditions, we've got you covered. Now, unconsolidated formations might sound like a mouthful, but picture this. You're trying to suck a milkshake through a straw, but the milkshake is full of sand. That sand, my friends, is your enemy downhole. It can chew up equipment, plug your well, and generally make a multi-million-dollar operation grind to a halt. So, why should you care? Because getting this right means the difference between a gusher and a bust, between a smooth operation and a costly nightmare. These aren't just abstract engineering concepts. These are real-world solutions developed by hardworking men and women who aren't afraid to get their hands dirty, figuratively, and sometimes literally. We're talking about formations that just don't want to hold themselves together, loose sand and rock, that would rather flow right up your well bore than stay put. It's a constant battle against geology. And today, we're looking at the best weapons in our arsenal. We're going to break down the nitty-gritty of several top-tier techniques, looking at how they work, where they shine, and what you need to consider before you pick one. This isn't just about theory, it's about understanding the practical application of some serious ingenuity. From stuffing gravel down a hole to using space-age expanding screens and even chemical wizardry, the goal is the same. Keep the oil and gas flowing and leave the troublesome sand behind. So grab your hard hat and let's get into it. This is where the real work happens. First up, we've got a technique that's been around the block a few times, a real tried and true method gravel pack completion. Now, when you hear gravel, you might think of your driveway, but we're talking about a very specific, engineered kind of gravel here. This method is the go-to when you're facing a high risk of sand production, which, let me tell you, is like trying to drink coffee with grounds constantly getting in your mouth. Unpleasant and ultimately clogs everything up. It's particularly effective in your traditional vertical wells or even those wells that take a bit of a detour, what the industry calls deviated wells. The principle is simple, but the execution, that takes skill and precision. You're essentially building a downhole filter, custom-made for your well. So, how does this whole gravel packing shebang actually work? Imagine you've drilled your well, and you know that formation is just itching to cough up sand. What you do is run a special kind of pipe with slots or holes in it, called a screen, down into the well, right across from that problematic sandy zone. Then, and here's the clever part, you pump a slurry of precisely sized gravel down the annulus. That's the space between the screen and the casing or the open hole. This gravel settles around the screen, forming a permeable barrier. It's like building a tiny, super strong retaining wall deep underground. One that lets the good stuff, oil and gas, flow through while holding back the bad stuff, sand. The big advantages here are pretty compelling. First and foremost, it's incredibly effective at sand control. When done right, a gravel pack can stop sand in its tracks, protecting your downhole equipment, your surface facilities, and ultimately, your production rates. Think of it as a bouncer for your well bore, only letting the VIP's oil and gas molecules get through. Another major plus is its operational life. These things are built to last. A well-completed gravel pack can keep a well-producing sand free for years, even decades, which in this business means a more reliable and profitable operation. It's an investment upfront for long-term peace of mind. But like any job worth doing, it's not without its challenges. Getting that gravel uniformly placed around the screen, especially in long, deviated or horizontal sections, can be tricky. If you get voids or bridges in your gravel pack, sand can find a way through, and you're back to square one. It also requires careful design. The size of the gravel has to be perfectly matched to the size of the formation sand and the screen slot openings. Too big, and fine sand gets through. Too small, and you might restrict the flow of oil and gas. It's a balancing act, a bit of an art and a science performed thousands of feet below the surface. Now let's talk about a slightly more streamlined approach, what the industry calls a standalone screen, or SAS. This is often your go-to when you're drilling those long horizontal wells, stretching out like underground highways, especially in formations that are, shall we say, only moderately cranky about holding themselves together, moderately unconsolidated. Unlike its big brother, the gravel pack, the SAS, as the name implies, goes it alone. There's no comforting blanket of gravel pumped around it. Here, the screen itself is the star of the show, the primary line of defense against that pesky sand. It's a bit like sending a soldier into battle with just a specialized shield, relying on its design and the soldier's skill. So, how does this solo act perform its sand-stopping magic? It all comes down to the screen's design, particularly the size of its openings or slots. These screens are engineered with incredibly precise slot widths, tailored to the specific grain size of the sand in that particular formation. The idea is that the larger formation sand grains will bridge across these openings, forming a natural stable filter cake right at the screen's surface, while still allowing the oil or gas to flow through. It's a delicate dance. The formation itself also needs to have a bit of inherent stability. If it's too loosey-goosey, the sand might not bridge effectively, or the formation could collapse around the screen. One of the biggest draws for the SAS technique is its relative simplicity, and consequently, lower cost compared to a full-blown gravel pack. You're eliminating a whole step the gravel pumping operation, which means less equipment, fewer materials, and crucially, less time spent on the rig. And as anyone in this business will tell you, rig time is money, big money. So if you can achieve good sand control with a simpler, faster method, that's a huge win for the project's economics. It's about being efficient without compromising the integrity of your well, a smart way to work when conditions allow. However, going standalone isn't a universal solution. It's not for every well or every formation. The success of an SAS heavily relies on accurate formation evaluation. You really need to know your enemy, specifically the sand grain size distribution and the formation stability. If you get that wrong, or if the formation is more unconsolidated than you thought, you could end up with